Hi there, and welcome to this lesson. In this lesson, we'll be learning about trigonometric quadrants, okay? And under trigonometric quadrants, we'll be learning trigonometric ratios of angles greater than 90 degrees. Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So for some time now, we've been talking about trigonometric ratios, okay, and we've been learning about right-angled triangles, and we're still on trigonometry, but we're going to be doing something quite different, okay, this time around, okay, and we're no longer going to be working with right-angled triangles. We're going to push trigonometry further because trigonometry is actually a lot broader. It goes well beyond right angle triangles, and we're going to be learning about trig because obviously you can't have an angle greater than 90 degrees in a right angle triangle, but you most definitely have trigonometric ratios for angles greater than 90. So you can actually find sine 120, sine 250, and the greater angles basically. And this lesson we're just going to learn how can you find sine 250. Now we're going to be learning about trigonometric ratios of angles on an xy plane. Okay, and an xy plane is your graph. Okay, the x-axis, the y-axis, and we're going to be learning about angles on an xy plane. And an xy plane goes from 0 degrees all around round back to 360 degrees. Okay, so it completes a full circle, and we have our xy plane here with our x-axis and our y-axis. Okay, and basically if you look at what we have the xy plane divided into four quadrants. Okay, this here is the first quadrant, this here is the second quadrant, this here is the third quadrant, and this here is the fourth quadrant. Now you notice how I label them. Okay, so basically starting from the x-axis going counterclockwise. Okay, and if you don't know what counterclockwise is, you know how a clock moves. A clock moves basically from 12 to 3 to 6 to 9 and back to 12. But when we're doing angles, if you look at your clock face, we're actually going to be going in the reverse. So we'll be going from 12 to 9 to 6 to 3 and back to 12. Or rather from 3, basically when we're doing angles, start from 3 to 12 to 9 to 6 and back to 3. Okay, if you look at a clock face and you know exactly what I'm talking about. So we're going anti-clockwise. So we have our first quadrant, second quadrant, third quadrant, and fourth quadrant. And something very, very interesting about our four quadrants, okay, is if you look at your graph sheet, if you remember your graph sheet, basically on the first quadrant, the y-axis is positive. Okay, just think about plotting a graph. Okay, the y-axis is positive when if you're going upwards. Basically, look at that first quadrant. You have the positive y and the positive x. Okay, the values on the x-axis will be positive, values on the y-axis will be positive as well. For your second quadrant, however, the values on the y-axis would be positive, but the values on the x-axis would be negative. Okay, look at the second quadrant. Positive y, negative x. What about the third quadrant? In the third quadrant, the y is negative because you're going downwards, and the x is also negative because you're going to the left. And then for your fourth quadrant, y is negative because you're still going downward, but x is positive because you're going to the right. Okay, so just think about your graph sheet, how you normally plot your graphs, and you're going to understand exactly what I'm talking about here. In the first quadrant, you have positive y, positive x. Second quadrant, you have positive y, negative x. In the third quadrant, you have negative y, negative x. In the fourth quadrant, you have negative y and positive x. Now, the essence of all of this is basically because we usually identify the vertical axis as our opposite, and then the horizontal axis as our adjacent. And whether they are positive or not will play a very, very fundamental role in determining whether the trigonometric ratio in a particular quadrant is positive or negative. Yes, we're actually going to be having negative trigonometric ratios, and that's pretty much what we'll be doing in this lesson. So let's go on. Okay, now we've talked about the quadrants. The next bit we're going to talk about is angles in the trigonometric quadrants. Okay, and this is actually really simple, just how you identify the angles in the quadrant. And what it is in the quadrants, what it is you start here. This is 0 degrees, okay, and then we have 90 degrees right at the top. Okay, so you go from 0 to 90, and then you have 180 degrees. Okay, so 90, 180 degrees, we're just measuring the angles. You have 270 degrees, and then you get back to 360 degrees. So you form a full circle moving anti-clockwise with intervals of 90 degrees. Okay, and then basically if you have an angle in this first quadrant, this angle is going to be between 0 and 90 degrees, okay? Somewhere in the middle between 0 and 90 degrees. So this could be 45 degrees, this could be 60 degrees, this could be 87 degrees. It's going to be somewhere between 0 and 90 degrees. Now, if you keep moving and you move over to the second quadrant, you're going to have angles between 90 degrees and 180 degrees. So 120 would be here, 150 would be here, 170 would be here, 110 would be here, 109 would be right here, 97 would be in here. So any angle between 90 degrees and 180 degrees you'd find in your second quadrant. What about the third quadrant? 225 degrees, you'd find it here. 245 degrees, 250 degrees we mentioned earlier, 190, 200 degrees, they'd all go in the third quadrant because they're between 180 and 270. And then finally you have 270 and 360. Now 325, 347, 298, all these angles would fall in here, okay? And we can find the trigonometric ratios of all of these angles using trigonometric quadrants, and that's pretty much what we're doing, but we're getting there step after step. Okay, so we identify the four quadrants and the angles you would find in the four quadrants. The first one 0 to 90, the second 90 to 180, the third quadrant 180 to 270, and the fourth quadrant 270 degrees to 360. So let's determine the quadrants in which the following angles lie. So I have 51 degrees, 225 degrees, 295 degrees, and 140 degrees. Now, for 51 degrees, we have our first is typical acute angle, first quadrant, okay? 225 degrees is between 180 and 270, so 225 degrees will be in our third quadrant. And then 295 degrees is between 270 and 360, so it will be in our fourth quadrant. And then 140 degrees is between 90 and 180, so it will be in our second quadrant. Simple, okay? So we're getting there, okay? And we're going to learn how to find the cosine of 250 degrees. And basically we've learned about the XY plane, the different quadrants, what they represent. We've now learned about the angles in the four quadrants, where the angles belong in the four quadrants. The next thing we're going to learn about is the trigonometric ratios in the quadrants, okay? And we have this acronym for it. We have CAST, cast. Okay, just remember cast, all right? And what I have my four quadrants, okay? And I'm just going to write, look, watch closely. I say CAST, okay? Now you need to be very careful about this. A goes in your first quadrant. You actually start labeling from your fourth quadrant, okay? It's something, it just works in that manner. But when you find out exactly what these represent, you remember that you start labeling from your fourth quadrant, where you say CAST, okay? And you're moving counterclockwise. And what you have now, if you look at the first quadrant, basically we have A in there, all right? and A stands for all, ALL, all. Okay, and what that means is that all three trigonometric ratios in the first quadrant are positive, and that's pretty much all we've been working with for some time now. Basically, we've been doing angles between 0 and 90 degrees, and we've never come across a negative trigonometric ratio. They've all been positive. Sine is positive, cosine is positive, tangent is positive. Okay, now if we move over to the second quadrant, we have S, and what that stands for is sine. Okay, and in this quadrant, sine alone is positive, the other two are negative. Okay, and here's why. If you look back at what we did when at the start, okay, the XY plane is divided into four quadrants: the first, second, third, and fourth quadrant. And in the first quadrant, Y is positive, X is positive. In the second quadrant, Y is positive and X is negative. Okay, now just assume your hypotenuse is always positive. Okay, and then your y-axis represents your opposite, your x-axis represents your adjacent. Okay, now if you have a positive opposite divided by a positive hypotenuse, you'd have your sine as positive. If you have a negative adjacent divided by a positive hypotenuse, you have your cosine as negative. If you have a negative, because x is always negative, if you have TOA, opposite over adjacent. If you have a positive opposite, positive y, divided by a negative x, you would have your tangent as negative. And that's pretty much what all of this stands for. Okay, but if you're looking to remember, just remember CAST, and you can always tell which one is positive and which one is negative in all four quadrants. Now, for the next one, basically, we have T, and in this quadrant, tan is positive and the other two are negative. And the reason for this is we have in the third quadrant, Y is negative, X is negative. So what we have here is we have a negative opposite and a negative adjacent, okay? And then if you have, like I said, assume the hypotenuse is always positive. If you have your negative opposite divided by your positive hypotenuse, you will have a negative sign. If you have negative adjacent divided by a positive hypotenuse, you'd have your negative cosine. But if you have your negative opposite divided by a negative adjacent, you end up with a positive tangent. Okay, and that's why tan is positive in this quadrant. And then finally, we have our fourth quadrant. And this quadrant cosine is positive because in our fourth quadrant, y is positive and y is negative and x is positive. And basically what we have a negative opposite and a positive adjacent. And what this means, we have a negative opposite divided by a positive hypotenuse. Like I said, always assume your hypotenuse is always positive. And what we have is we have a negative sign. Okay, a positive adjacent divided by positive hypotenuse gives you a positive cosine, and a negative opposite divided by a positive adjacent gives you a negative tangent. And that's the reason for all of it. But just, you don't need to get into all of this. Just remember CAST. C stands for cosine is positive, A stands for all trigonometric ratios are positive, S stands for sine is positive, and T stands for tangent is positive. Okay, and let's do a short exercise. Basically, determine whether the following trigonometric ratios are positive or negative. So we have sine 180, sine 120, cosine 290, tan 150, and cos 110. Okay, and basically we're going to go ahead and say sine 120 is in our second quadrant. Okay, because 120 is between 90 and 180, and in that quadrant sine is positive, so sine 120 is going to be positive. Cosine 290 is in the fourth quadrant. Okay, and in this quadrant cosine is actually positive, and for that reason cosine 290 is going to be positive. What about tan 150? Tan 150 is in the second quadrant, and in this quadrant tan is not positive, tan is actually negative. So in this quadrant tan 150 is going to be negative. And then we have cosine of 110. Cosine of 110 is in our second quadrant. And in this quadrant, cosine is negative. So cosine of 110 is most definitely going to be negative. Okay, so we've learned about our quadrants. Okay, we've learned how to identify the angles in the quadrants. We've learned to determine whether the trigonometric ratios are positive and negative. Now, the one final thing we need to know is how to get the actual values. Okay, so basically we know that sine 120 is positive, but positive what? Or sine or tan 150 is negative. Negative what exactly? So the actual value of the trigonometric ratio. And to do that, we're going to be talking about origin angle. Okay, and the origin angle alpha of a given angle theta is an acute angle whose trigonometric ratio is equal in value to that of the given angle. So let's just break this down. Basically, if you're looking to find the trigonometric ratio of a given angle that's greater than 90 degrees, there is an acute angle whose value is equal to your given angle. Okay, and basically the first thing you need to do when you look into it is to find this angle and then find the trigonometric ratio of this angle, because this is where you find, when you have the trigonometric ratio of this angle, you have the trigonometric ratio of your given angle. Okay, and to find this, basically there's a relationship here. What it is, the trigonometric ratios of angles in the first quadrant are pretty much straightforward. Okay, so you just find them as you normally do. But then for the second quadrant, okay, so you have an angle like this in the second quadrant, and this angle obviously is greater than 90 degrees. So you can see theta there. Okay, going from 0 counterclockwise, you have your angle. It's an obtuse angle. It is greater than 90 degrees, and then we're looking to find a trigonometric ratio or a trigonometric ratio of this angle here. What we do is we always find the origin angle is the angle that lies on the horizontal. Okay, and basically this is your origin angle. So if you have theta there, alpha is this angle here. And if you look closely for this second quadrant, okay, alpha and theta would sum up to give you 180. Okay, so if you have theta and you're looking to find alpha, you just subtract theta from 180 degrees. Okay, now similarly for the third quadrant, basically we have an angle in the third quadrant here, very large angle, and we have theta. Theta goes all the way down there. Like I said, the origin angle is always the angle with the horizontal. It's this angle here. Okay, and if you look at what we have here, you'd find that theta is actually bigger than 180, and theta minus 180 would give you your origin angle. So basically what you have here is you have alpha equals theta minus 180. Okay, and then finally for the fourth quadrant, you have this very big angle here, okay, a reflex angle, and we're looking to find our origin angle, which is going to be this angle here, and it's basically just 360 minus theta. So if you look at the three of them, they don't follow a pattern. Okay, they're quite distinct. You really just need to know exactly what's going on here. Okay, the origin angle is always the angle with the horizontal. Okay, and for the first one, basically if you look at what you have there for the second quadrant, you look at what you have there, you have that the two of them will sum up to give you 180. So your origin angle is 180 minus theta. The second one, the angle is actually bigger than 180, and the difference is your origin angle. Okay, so you have, in that case, you have theta minus 180. And then for your fourth quadrant, you just have a going all the way around. Okay, and then you just left with that. What you have is you have 360 minus that big angle will give you that acute angle that you need to find. Okay, and now let's just go ahead and do one very short example. Okay, we have pretty much everything we need to know. Okay, for example, if you're looking to find the cosine of 150 degrees, 150 degrees is in the second quadrant, okay? And you need to find the origin angle of 150 degrees. It's an acute angle whose trigonometric ratios are equal to the trigonometric ratios of 150 degrees. And you say 180 minus 150, that gives you 30 degrees, okay? And the values for the sine of 30 degrees equals the value for the sine of 150. The value for the sine of cos 30 equals the value for the cos of 150. The value for the tan of 30 equals the value for the tan of 150. Now, whether these values are positive or negative, you need to go back to cast here. Okay, and let's do a simple example. Okay, so here find the value of cos 120 degrees. Now 120 degrees is in the second quadrant, and this quadrant cosine is negative. Now, the origin angle for an angle in the second quadrant is 180 minus the angle. So we have 180 minus 120 gives you 60 degrees. That's your acute angle that you can quite easily find straightforward. Okay, you can find the value of cos 20 straightforward, and basically you have that cos 20, not cos 20, cos 60. You have that cos 60 equals 0.5. So for cos 120, the value is 0.5. Well, as we already established, cos in that second quadrant is always negative. And for that reason, cos 120 is minus 0.5. Okay, it's a very, very simple process. Okay, now you need to identify, the first thing you need to do is identify the quadrant in which your angle falls in. Okay, and in this case, we have 120. That's the first bit, and then we need to find, we look at 120 and we see is the cosine positive or negative in that quadrant. It's negative, okay, and then we know that the cosine of 120 is negative, but now we need to find the actual value. And to find the actual value, we need to find the origin angle, and the origin angle in that quadrant is 180 minus your given angle. You get your origin angle, and then you find the cosine of your origin angle. It gives you the value, okay, and then you go, okay, so we have that cosine of in the second quadrant is always negative, and we just add a negative to that value. So cosine of 120 is minus 0.5. Now if you're looking to do the sine of 120, for example, you would also be making use of the same origin angle. Okay, the sine of 120 and the sine of 60 degrees are always equal in value. Okay, now whether that value is positive or negative comes down to your cast table. Okay, and then the second quadrant sine is positive. Okay, the sine of 60 is 0.8660. Okay, and then the sine of 120 is 0.8660. Is it positive or negative? It's positive, so it's just this is pretty much the same, positive 0.8660. So sine of 120 equals 0.8660. So it's really that straightforward. Okay, the first thing you need to do, you identify the quadrant in which your angle lies. Okay, and then determine whether or not that angle is positive, the trigonometric ratio is positive or negative, okay, using that cast diagram. And then right after that, you need to find the origin angle to give you the actual value. Okay, and then when you have the actual value, you just bring the two together. Okay, actual value and whether it's positive or negative. If it's negative, you just negate the value. If it's positive, you leave it as is. Okay, and that's pretty much it. Very simple, very straightforward. Again, we'll be exploring very, very, very interesting bits of trigonometry. What we're talking about, we'll obviously be working more with angles that are greater than 90 degrees. And yeah, you can go ahead now and attempt questions on the worksheet. Bye for now.